The next example, find the critical numbers of the functions f of x equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5, and determine the interval on which f is increasing and interval on which the function is decreasing. Right, so to find critical numbers, you're going to find the first derivative of the function and set that equal to 0. Right, so first determine the critical numbers. So take the first derivative of the functions. You have 12x cubed minus 12x squared minus 24x and set that equal to 0. You're going to solve this. You see that 12x is the common factor. You left with x squared minus x minus 2 equal to 0. And you can factor the quadratic expressions inside the parentheses. And you get this is 12x times x plus 1 times x minus 2 equal to 0. So you have three critical numbers. So the critical numbers are x equal to -1, x equal to 0, and x equal to 2. In order to identify the interval on which f is increasing or decreasing algebraically, so what you can do is draw the real line with x equal to -1, x equal to 0, and x equal to 2. Right, so this is the real line. You have this is -1, this is 0, and this is 2. There are two parts to this real line. The first part is for x values. Right, so we have -1, 0, and 2. Those are the critical numbers. And on top here, you need to consider f prime of x. Right, so f prime of x, that's how you find the critical numbers. At x equal to -1, x equal to 0, and x equal to 2 are the solutions to these equations, right? So therefore, f prime of -1 is going to be 0, f prime of 0 is going to be 0, and f prime of 2 is 0 as well. So -1, 0, and 2 are critical numbers, and they are also the factor of f prime of x. So when x equal to -1, f prime of -1 is equal to 0. So on and so forth. When x equal to 0, f prime of 0 is also equal to 0. When x equal to 2, f prime of 2 is also equal to 0. All right. To identify the interval increasing or decreasing, you need to test the sign of the first derivative. If f prime is negative, the function is decreasing. If f prime is positive, the function is increasing. Right. So therefore, you're going to test some numbers in this interval. Right. There are 4 intervals in this case, from -infinity to -1, from -1 to 0, from 0 to 2, and from 2 to positive infinity. Right. So that's what you're going to do next. Test the sign of f prime of x in the intervals -infinity to -1, -1 to 0, 0 to 2, and 2 to positive infinity. So you have 4 intervals to consider. And how could you test the sign? Right. You test in the interval of -infinity to -1, just choose any number in that interval and substitute into the derivative functions. So in -infinity to -1, I choose x equal to -2. The easier for you to calculate, the better. But do not choose the endpoint. Right? Do not choose the endpoint. Okay. Anything else is fine. Do not choose the endpoint. Right. So I choose x equal to -2, and I substitute that into the derivative functions, and I get f prime of -2 is equal to 12 times -2 times -2 plus 1 times -2 minus 2. Because you just want to test the sign of the first derivative, you don't have to fully calculate the number. Just consider the sign of the calculations. Right? So what do I mean by that? I know that 12 times -2, I don't know exactly the value, but I know this is going to be a negative number. -2 plus 1, I know that's also a negative number. -2 minus 2 is also a negative number. So negative times negative times negative is going to be a negative number. So I say that in this interval, f prime is going to be negative. So I know that the function is going to be decreasing in that interval. Now between the interval of -1 and 0, choose any number. The easier for you to calculate, the better. So I choose x equal to -1/2. Once again, do not choose the endpoints. Right? So f prime of -1/2 is equal to 12 times -1/2 times -1/2 plus 1 times -1/2 minus 2. So once again, don't have to fully calculate the result. You just need to look at the sign. So 12 times negative 1/2 should be a negative number. Negative 1/2 plus 1 should be a positive number. And negative 1/2 minus 2 should be a negative number as well. Therefore, this is altogether, this is a positive number. So f prime in this interval is positive. So you go up here, you put the plus sign to indicate that in that interval between negative 1 and 0, the function is increasing. And you do the same for the last two intervals. So in 0, 2, I would like to choose x equal to 1. So what is f prime of 1 equal to? 12 times 1 times 1 plus 1 times 1 minus 2. I'm saying this is positive, and this is negative. So therefore, in this interval, f prime is negative. And in the last interval from 4 to positive infinity, I would like to choose x to be equal to 5. So I have f prime of 5 is 12 times 5 times 5 plus 1 times 5 minus 2, and this is obviously a positive number. Now you make the conclusions, right? Because what are we looking for? We are looking for the interval on which f is increasing or decreasing, right? And from this table, from this test, you'll be able to draw the conclusions that so f prime is less than 0 in the interval from negative infinity to negative 1, and from 0 to 2, f prime is greater than 0 in the interval from negative 1 to 0 and from 2 to positive infinity. Right? And you also draw the conclusions that f is increasing on the interval from negative infinity to negative 1 and from 0 to 2. F is decreasing on the interval from negative 1 to 0 and from 2 to positive infinity. So I'm going to move on to something called the first derivative test. So suppose that c is a critical number of continuous functions. Then I say that f is a local maximum as c if f prime changes from positive to negative. Makes sense, right? Because from positive to negative, that means the function is increasing and then decreasing. Then the point that meets that change is going to be a maximum, right? That's the turning point, right? It turns from positive to negative, or turn from increasing to decreasing. You have that as the local maximum. Now, the second part is f is a local minimum as c if f prime changes from negative to positive, right? That means the function changed from decreasing to increasing, right? So they meet at this point, and that is turning point. The turning point is a local minimum. The last part is if f prime does not change sign, there is no extreme values. Right, so let's go back to the example earlier to recap, to kind of like elaborate this first derivative test. Let's say that f is the local maximum if f prime changed from positive to negative. Right? So go back here, look at the table, and look at this table. It changed from positive to negative, so the maximum occur at x equal to 0. This change from negative to positive, a minimum will occur at this point. A minimum will occur at this point as well. Right. I don't know exactly what the point yet, but I know for sure that there will be a minimum here, and a maximum here. All right, so let me look at another example here where I'm going to consider critical numbers, identify increasing and decreasing interval, and also identify a local maximum, local min using the first derivative test. Example, find the local maximum and min of the functions f of x equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5. This is the previous example, right? So I'm going to bring in the real line again. You have negative 1, 0, 2. Those are critical numbers that we found from the previous example. That is x. This is f prime of x. At the critical numbers, x prime equals to 0, and the sign is negative, positive, negative, positive. And f of x is going to be decreasing, increasing, decreasing, and increasing. So decreasing to increasing, this is a local minimum. Increasing to decreasing, this is a local maximum. This point is a local minimum as well. So they want to find the local maximum and local minimum of the function, so we're going to evaluate that. Right? So we use critical numbers to evaluate the local minimum and local maximum. For x equal to -1, so f of -1, you substitute that into the original functions, right? So 3 times -1 to the 4th minus 4 times -1 cube minus 12 times -1 square plus 5. That should give you 0 for this particular calculations. At f of 0, you have 3 times 0 to the 4th minus 4 times 0 cube minus 2 times 0 square plus 5 equal to 5. For f equal to 2, you have 3 times 2 to the 4th minus 4 times 2 cube minus 12 times 2 square plus 5. And I calculate this is negative 27. And you can draw final conclusions here. You can continue right below it, but I just want you to show the test here. So that's why. So local min equal to 0 at x equal to -1. Local max is equal to 5 at x equal to 0. And another local minimum equal to -27 at x equal to 2.